Okay, hang on to your seats. This is going to be quick and furious. Part of what I like to do here is a little bit of education about what things you should ask from a platform standpoint. So we're going to zip through some particular features of Numerex's platform. And by the way, these slides will be available at the end, so you don't have to take notes while we're going along. There's a safe harbor statement. We're a public company, so I have to do this. There'll be a test at the end. We're going to be talking about the platform, KPIs, customers and ROI, applications and partnerships. Our platform is device, network, and application. It's comprehensive. We do managed services across end-to-end for the device, the network, and the application. That includes off-the-shelf type devices, also devices that we actually manufacture ourselves in addition to a reference design. We include our own network, not an MVNO. We actually have GGSNs, HLRs, AAA, radio servers, diameter, that kind of thing, and also do satellite in addition to cellular. And at the application area, we also have, as you'll see, a managed service platform that includes hosting capabilities. Key principles of our architecture is that it's completely redundant. It's based on a SOA type architecture. It's componentized, so you can actually distribute it throughout different geographical areas. Every component's stateless, so you can actually do things from a reliability and performance standpoint that are important. It's cloud, but hybrid cloud-based. We have some pretty interesting data integrity ROIs and KPIs and things like that, and I'll show you some graphs about things you need to look at relative to a platform and how to measure its performance. And then we have all kinds of predictable connectivity options about it. This is an architectural diagram from a logical standpoint. As you can see, from a carrier standpoint, we have a number of different carriers at the bottom, including AT&T, Sprint, Verizon, Telefonica, Rogers, Telenor, Cineverse, and Globalstar. We have our own STPs, so we connect through SS7 into the network. We have core packet backbone, as I described, with most of the components. I call it just the right infrastructure relative to cellular connectivity. And all the business analytics are at an application layer and also the applications. Key technologies, I'll let you refer back to this slide, but this gives you an idea of what the key technologies are internally to our systems from a device, a network, an application, and also DevOps. And DevOps is probably one of the most important aspects of deploying M2M systems these days, because basically you need to change the wheels on the bicycle as it's going down the road. And I have a graph which shows exactly that we have that capability. This shows our hardware at the D side, the device, some of the devices we actually manufacture ourselves, a device platform to enable people to be able to get up with a fully certified PTCRB and FCC platform and be able to do that at a very low cost, and we'll license that bill of materials for you to be able to manufacture it yourselves. And also we have hundreds of third-party devices that we have on our network. By the way, Numerex is a public company. We have about 105 employees, and we currently have about 2.5 million devices on our network. This is the core network from the logical standpoint. You can see that the carriers are on the left. The middle part is our platform, which includes all of the components that I described earlier, in addition to systems that have to do very specifically with some M2M expertise that we have in the security arena, which is where I'll be focusing in security. So, for instance, two-way voice and video are addition platforms within our network layer. It's all on a clustered common core with high availability through VMware, if you're familiar with that, which allows us to be able to pull things and put them back in all in real time. There's no single point of failure. Everything's redundant. We use all the different types of very sophisticated, both open source and written internally, usually with Java capabilities to do messaging. Messaging is probably one of the most important portions of a platform, and our messaging, the folks that do that are folks that come from places like Twitter and the financial services industry, where you can't have packets fall on the floor, and they have to go through with a very low latency. Hybrid cloud, it's VMware, geo-redundant, high availability. We use AWS for some of our storage backup and some of our big data analytics type stuff. It's completely OpenStack compatible, and as I said, it's a layered SAO. So from a platform standpoint, you also have to think about some of the boring stuff, the provisioning we do bill on behalf of. We have active management capability at the device, the network, and the application layer, all integrated into a single portal to be able to do that communication, or through web services. And of course, you have all the control mechanisms to be able to control those types of aspects. The production environment is geo-redundant, as I described, in 2 different data centers with a complete MPLS background. If you're familiar with things like BGP routing and the capability to peer on a BGP basis with your own autonomous system domain to be able to peer with others, that's very important from an IP packet transport, and it becomes even more important as you move towards LTE. For the development process, we use all the newer techniques relative to deployment, including agile processes, code coverage, unit integration, automated test, automated deployment using things like Rundeck, Capistrano, and Docker. And we do code audit for both vulnerabilities and code audit for open source. Our big data analytics are very interesting. We'll get into that in a little bit of detail. We do real-time traffic analysis. We actually capture about somewhere between 6 and 12 terabytes a month of every single packet that goes across our network, either IP or SS7. And we use things like Hadoop to be able to do batch analytics on that, both at a deep packet standpoint and also at the network layer. And we also use things like Spark and Storm to be able to real-time streaming analytics on that. Give you an idea of one of the aspects that I've been talking about for years is we have 2.5 million devices on our network, so we've gotten to scale earlier than many other companies and run into those types of problems. We've had to deal with them earlier. One of the things that I talk about is transient analysis, particularly in networks with M2M devices that are through the cellular network. And by transient, what I mean is steady state's pretty easy. The problem is that in cellular networks, a lot of times you get basically constipation in the network. And what happens then is that all of a sudden there's this huge flow of packets. And the question is how your system is resilient to that transient response. Well, you can see here at the top is a graph basically of how we did a deployment using DevOps in real time to be able to show adding additional capability. You can see that the graph on the top is where you see the numbers of packets per second all of a sudden jump up. That was when we actually added onto the system an additional customer that had a large number of devices that we transported over into our system. And you can see that the system took it in that kind of a transient nature quite easily. In addition, we have all kinds of analytics to be able to see messages and pass through and the message latency as they move through the system at all kinds of different areas. As you can see on here, we have all types of SLAs. In this particular case, it's an SLA based on for a large MSO cable company that's doing security, where they want to have all of their devices completely connected 100% of the time to the GGSN so that if there's an alarm that goes off the home, there is no latency. And so you have to provide SLAs and the graph of those. And the spike down in the bottom of this is actually when one of our network providers lost the connectivity on the SS7, the STPs. And we had to move over to another carrier to be able to compensate for that. And then it came right back up again. Another transient response problem. One of the other things we do is we look at the SS7 and all the packets that go through the network. We can actually do some interesting prediction in real time. This particular one, you can see the mix changing on AT&T's network. And what we predicted 7 days before they told us was that they actually were taking out a VLR. And so we were able to actually respond to that VLR change before they even told us that it was going to happen. The other thing we do is we look at costs and things like that. In this particular case, each one of these little tadpoles are moving around on a weekly basis on SS7 charges relative to a baseline of the number of devices they have and the number of SS7 messages. These are in alarm systems which use a lot of text messaging, SMS, in order to transport. And so what we're trying to do for our customers is actually get them down to a normalized line of all the other customers that have the same kinds of systems. And so these are the kind of graphs that you can provide for your customers to be able to reduce their costs from a network usage standpoint. This is another example of the architecture of the system. You can see at the bottom it's 2G, 3G, 4G, LTE, CDMA, satellite, Wi-Fi, IP, and then you move up the stack to services layer and all the way up to the application layer. We have a number of partners that we work with, both on the device, the connectivity, systems integrators, technology partners, and also channel partners. Our solutions primarily go into 4 different categories: security, asset ID and tracking, supply chain, and remote monitoring. The highlighted customers in each of those areas are here. And then we have a number of applications that I'm going to go through very quickly. Manufacturing and distribution. In emergency response, we provide FEMA. tracking application and satellite. Energy and utilities down at well sites. We're doing well site management and also tank level monitoring. This is an application in the water and energy arena, both mobile applications and also online. Energy and utilities, oil and gas, pump on off control and well sites. Also downstream, telematics for vehicle tracking, public safety. This is alcohol testing, alcohol breath monitor testing. This is a left ventricular heart disease, device to be able to track people that are about to get heart replacement. Focus on security just for a moment. Residential security, fire detection, home automation, and commercial security. The technologies are basically the gamut. 3 of the big customers, 2GIG, Next Alarm, and United Technologies. Some of the devices down below either manufacturer or third party. This is the alarm communicator where you can go to your house and open your door and turn on your lights and that kind of thing. We have the complete back end for both the video and the voice infrastructure for this. Obviously, security is very important inside security, so this is an emergency response system we do for Verizon that you may be familiar with. If you go to Verizon store, you can find it for tracking. In the oil and gas industry, this is for an asset monitoring application. In covert monitoring, we do both covert monitoring of devices. We also do covert monitoring of offenders. This is an alarm system that's a self-service deploy alarm system. In child monitoring, this is a child tracking system we do through Sprint, if you're familiar with WeGo. In offender monitoring, this is the tracking system for offenders. Very difficult but interesting application where we've used the indoor location capability here with Kalman filtering and others with sensor fusion, and we apply it to our asset tracking so we can actually track devices inside of factories and warehouses. From a security standpoint, you got to worry about the sensor, the ISM short-range device, the device in the network, the application, and also things like web services in the database. There's attack vectors in an ISM standpoint in Zigbee, Z-Wave, ANT+, Bluetooth LE. They all can be compromised. Trust me, I know this. I do this for a hobby. M2M network attack vectors, you have to worry about the device, the module, WAN, the server, the internet and LAN, denial of service attacks, spoofing, revenge. And I've given you a list of, and a couple of slides of some very interesting attack vectors relative to security that we keep on top of mind. But there's all kinds of certifications and things like that you also have to implement. We're ISO 27001 certified from a security standpoint. And, excuse me. Many different access controls in order to make sure that the right people have access from a AAA standpoint to your system. And here, the last thing I'd like to do is do a quick customer testimonial. This is a bank. Unfortunately, I'm not able to tell the name of the bank because of their security requirements, but the bank customer, because of the security policy, wishes to remain nameless. The device on the right-hand side is one that we manufacture. There are a number of security protocols that are built inside of it to make sure that the actual code inside of it, for instance, can't get compromised. I'm going to talk about the description, the value prop, the ROI, and some KPIs. This particular description of this device goes inside of an ATM machine and transmits up information based on, excuse me, things like whether the door cash box is open, whether it loses power, whether there's a network outage, whether the cash dispenser is empty. It's a remote. It has remote capability for initial reboot, and it also protects both the cash inside and also the ATM machine itself. Beforehand, you had all kinds of unfortunate circumstances when people either stole a machine or we needed to go out and maintain the machine or reset it. Afterwards, though, and the cost of downtime was tremendous, afterwards, with the investment into this uplink device and our back-end platform, basically the payoff was within about 5 months. And if you included the fact that they didn't have to do remote on-field diagnostics and things like that, the payback was actually in about 2 months. So with that, I have 45 seconds left, if there's any questions. Thanks very much.
Applause.